Okay, so we're going to look at absolute value inequalities, and we're going to start with a little investigation to understand what the absolute value inequality means on a simple level before we take it to the more complicated equations. So the first thing we want to look at is the absolute value of k is greater than or equal to 3. And I'm going to put some numbers on this number line. You should put some on yours as well. And we want to think about what absolute value means. I just put from -5 to +5 on my number line. Okay. Absolute value, what is the definition? The distance away from 0. Okay, so when I have it ask me the absolute value of what numbers, that's what k means, right? What numbers will fit in here that have an absolute value that is greater than 3. What I want you to do is I want you to pick two numbers that are more than 3 away from 0 and put it on your number line. Pick two numbers that are more than 3 away from 0 and put it on this number line. Just put a dot for those numbers that you've chosen. And I'm going to ask you guys to throw some of them out. What are your numbers that you chose? -4. And +4. Say that louder. What's yours then?
Pi.
5?
Pi.
Oh, pi. I like it. Pi is greater than 3 away from 0. What else? There's got to be more. 5. -5. Who said 3? It's greater than or equal to, isn't it? So we can include 3 in that. And if we can include pi in that, can't we include all the decimals between 3 and 4 and 5 and 6? So what does that mean? I'm going to shade. I'm going to shade outwards from 3 and -3. A little. What is So my shading's a little off here, and it's not going to let me erase it. I'm trying to erase right here. Okay? So we usually use closed circles, right, on the numbers when it's greater than or equal to. So how do I write that compound inequality? How do we write the left side? How do we write this left side? K is less than or equal to -3. Now, is this and or? Or. K is what? What is the right side? Greater than or equal to +3. So in order for it to be true, it has to be greater than the positive or less than the negative, right? Okay. So now let's look at number 2. Can you give me a number whose absolute value is greater than -4? So when we were looking at, the question was, how do we know when it's or and? And when we're looking at this number line, it cannot be both, right? The number has to be either on this side, less than -3, or it has to be greater than the +3. This isn't a situation where it's given to us in the original problem, whether it's and or. in the compound inequalities we did yesterday, it's stated, right? So when we're looking at a number line and making that determination, the question is, can it be in both places at the same time? And the answer is no, so it has to be an or. Okay? Okay, so let's throw out some numbers that if you plug it in here, the absolute value of that number is greater than -4. 0. -3. 2. E. Ooh, where does E go? Very good. E. Getting creative. Pi, right? What are we getting from this? All of them, right? All numbers. Oh, I don't really want a black highlighter. That's interesting. All numbers. Because if I plug it into absolute value, it's always going to come out positive. And a positive is always bigger than a negative, right? So how do we write that solution? Oh, thought I had a pen. All real numbers. Sometimes. And then we're going to pen. And then we're going to write all real numbers. There we go. Okay. All right, so let's put our numbers on this number, the next one. We're looking for numbers whose absolute value, whose distance from 0 is less than 2 away from 0. So pick two numbers. Put it on your number line that have a distance from 0 less than 2. Two numbers who have a distance from 0 that is less than 2. All right, who wants to give me -1? 1. I think I heard 0. Does 2 count? No. But does 1.99 count? So how do I show that on a number line? I do an open circle, right? So all of these numbers that are shaded between -2 and +2 qualify as being less than 2 away from 0. Would you agree with that? Okay. And how do we write that solution? How do we write that between -2 and 2? There's 2 ways to write it. So we could say K. Keep starting writing with the. So we could say. K is less than 2. Right. K is less than 2. And -2 is greater than K. That's our one statement. Or we could write that K is greater than -2 and K is less than +2. Right? Yes.
Does it matter what numbers you use? Like -2 and 2, could you use -3 and
Not for this particular one. This says the absolute value has to be less than 2, so you have to use 2. If it said the absolute value was less than 3, then you would be using 3. And when we write this single statement here, notice a few things. The smaller number is always on the left. They are always both less thans. You cannot write it any differently. You cannot write it with greater thans. You cannot have them pointing at each other or pointing away from each other, and it always has to represent an and statement. Okay? All right, and let's look at the last one. Can you give me a number whose absolute value is less than -1? 0. The absolute value of 0 is that less than negative 1? No. Negative 2. What's the absolute value of negative 2? Positive 2. Is that less than negative 1? There is no solution, right? Just like the absolute value cannot equal a negative, the absolute value cannot be less than a negative. So this is no solution. Okay. So we're going to reference this when we look at our equations. When we're solving absolute value inequalities and we have a greater than, it's going to give us an or statement where one is greater than the positive or less than the negative. When we have the absolute value greater than a negative, it's all real numbers. When we have the absolute value less than, it's going to give us an and statement, right? And we're going to write them like this. You will never see me write them as two separate sentences because that's more work. I have to write and between those. Okay? Yeah. Who wants to do that? Okay? And then when we have the absolute value less than a negative, that's always going to be no solution because absolute value will always be positive. Okay? So down below you have 4 examples. You have some steps you can look at to help get you through there. We're going to do the first 2 together. Number 5, the absolute value of m plus 5 minus 2 is greater than or equal to 7. The first step is to isolate my absolute value, so how am I going to do that? I'm going to add 2. And the absolute value of m plus 5 is greater than or equal to 9. And then step 2 says write the correct compound sentence. Greater than, so I want to know, it's like cover up the m plus 5. Whatever's inside there has to be greater than 9, right? So m plus 5 must be greater than or equal to 9. Or what's the other option to make the statement true? M plus 5, what to negative 9? Has to be less than negative 9, right? Because it's more than 9 away from 0, so it has to be less than negative 9. Okay, so we want you to reference the number lines and the inequalities we wrote in the investigation. And then now what? Now it's just like yesterday's work, right? Minus 5, and m is less than negative 14, or minus 5, m is greater than or equal to 4. And what does that look like on a number line? Open circles, right? Closed, because I forgot to write my or equal to. Thank you. Questions? Okay, can we do number 6? What's our first step going to be for number 6? Divide by 4. So the absolute value of x minus 2 is less than 6. So we said less than 6 would have to be what? And, right? Between what 2 numbers? 6 and negative 6, right? So how do we write that? We wrote that negative 6 less than x minus 2 less than positive 6. You should get familiar with writing these compound sentences because a lot of the time we're not going to separate them as two equations. Okay? Now what? Add 2, add 2, add 2. So negative 4 is less than x less than 8. And my graph, these are open circles. Less than 8 and greater than 4 is between, or greater than negative 4 is between negative 4 and 8. Questions?
How did you get that top part, where the negative 6 and then...
This part here?
Yeah.
So I went back to what we talked about before. So we have to remember, and we have to reference those examples at the top of our worksheet for how to write this statement once we take it out of the absolute value and write it as a compound statement. Because all of your less than inequalities will be written like this as one statement. Okay? That whatever's inside the absolute value has to be between the negative and the positive of what it's equal to. And all of your greater thans will be written as two statements, greater than the positive or less than the negative. Okay? And then we have number 7. Is that a special case? The absolute value of x plus 9 is less than negative 15? Yes, this one has to be no solution. Because the absolute value can never be less than a negative. And what about number 8? The absolute value of 2y minus 1 is greater than negative 4. Is it no solution? Greater than a negative. When is the absolute value greater than a negative? Always. So number 8 is all real numbers. Okay.